Section 6. An ontology to accommodate consciousness? Stapp reasserts the orthodox quantum principle that reduction events occur at the boundary between the physically described and psychologically defined aspects of our scientific understanding of nature. Rejecting this, he says, this is what creates the hard problem in consciousness studies and makes a mystery out of how subjective experience arises from neural computation. Stapp identifies the principal problem with all quasi-classical approaches. Where within such an approach that does not involve consciousness, can one find either any reason for any reduction to occur at all, or any objective principle that specifies where between one single atom and the more than 10 to the power of 24 atoms in the brain do the collapses occur. Orthodox quantum theory ties these two problems of consciousness and collapse together in a practically useful way and provides simultaneously a way for the universe to acquire meaning. In other words, consciousness causes reductions in the brain, determines where they will occur, and consequently makes meaning in the human sense possible. The error in the classical approach lies, according to Stapp, in ignoring the fact that reduction events in the brain lead to increments in the subject's knowledge. Instead, such events are seen only in terms of classical physics. The problem with this, Stapp says, is that one loses the essential connection between physical description and subjective experience that quantum theory is designed to provide. This quasi-classical approach, as Stapp calls it, accepts quantum mechanics at the microscopic level, but ties reduction events in the brain to some objective condition of classicality rather than to the subject's experiences. As we shall see, this is a critique I want to make of the Penhov theory. This micro-level limit, as in Dennett's theory of mind and consciousness, is, Stapp says, at least somewhat better than simply accepting a fully classical conception of the brain, which ignores 100 years of development in physics. However, Stapp continues, in the context of solving the problem of the mind-brain connection, it inherits the fatal deficiency of the classical approach. The conceptual framework does not involve mind. In other words, in the classical approach, there's no place for or need for our conscious experiences. Indeed, classical physics provides no reason for consciousness to exist at all. Consequently, neither does it provide any principle as to how conscious experiences are tied to brain activity. The French physicist Bernard d'Espagne summarizes the perhaps unconscious philosophical outlook of the modern-day physicist. A realistically minded physicist of the last century could interpret physics as a faithful, though presumably incomplete, description of what really is. without encountering any difficulty internal to science, any objection to this standpoint could come only from a priori philosophical considerations. Even today, some physicists consider their science should hold fast to this ideal, but most of them assign a more modest goal to physics and to knowledge in general. Science, they say, and ordinary knowledge as well, is indissolubly linked with human experience. Once and for all, it must therefore give up the unattainable goal of describing whatever some thinkers may mean when they speak of reality in itself, or reality as it really is. This can also be described as giving up Newton's God's eye view of science. Despagna continues, the task of science can only be a description of the phenomena, that is, of things, events, and so on, as they are organized by human collective experience. The human means of apprehension and the human means of data processing on which this human experience rests cannot be kept out of consideration, and science should not try to do so. Despagna also says that the mathematical descriptions of quantum theory refer not exclusively to reality, but to a great degree to our minds as well. And Hodgson also dismisses so-called objective solutions to the measurement problem by concluding that there are reasons for questioning whether references to consciousness can be eliminated from any mathematics-based theory which is as satisfactory and comprehensive as the quantum theory. At this point, Despagna makes a link between this introduction of a mental dimension into physics with the philosophical views of Immanuel Kant. In order to try to resolve the dichotomies of Cartesian dualism, i.e. the divisions between mental and physical phenomena and mind and body, Kant posited a world of a priori forms. This deeper world underlies mind and matter and exists at a more basic level of reality. Examples of these a priori forms include space and time, and they are, according to Kant, necessary preconditions for human understanding. Despagna comments that the source of quantum physics certainly comprises parts of Kant's philosophical doctrine, but it is considerably less detailed and specific. Consequently, he says it is not necessary to be a Kantian in order to subscribe to philosophically quantum approaches to physics. In fact, says Despagna, such approaches constitute the explicit or implicit worldview of a great many thinkers and physicists of our time, most of whom have scarcely heard of and at any rate never took any interest in the Kantian philosophy. For short, let us refer to these people as phenomenologists. Personally, I believe that dual-aspect monism is a better philosophical doctrine to accommodate the Copenhagen-von Neumann-Stapper tradition in quantum physics, though, as we shall see, Stapp seems to prefer the simple description of dualism. Dennett attacks dualism as fundamentally anti-scientific, accusing it of wallowing in mystery, and asserts that to accept dualism is to give up. But, he says, despite widespread agreement among scientists about this, there's still a lot of psychological resistance, and indeed, perhaps a conceptual inability to give up the habit of conceiving of the world in dualist terms. Then it says that scientists and philosophers may have achieved a consensus of sorts in favor of materialism, getting rid of the old dualistic visions is harder than contemporary materialists have thought. Finding suitable replacements for the traditional dualistic images will require some rather startling adjustments to our habitual ways of thinking, adjustments that will be just as counterintuitive at first to scientists as to lay people. I think that adopting the dual aspect monist position while retaining a few of the assumptions of Cartesian dualism is different enough to require just as profound adjustments to our habitual ways of thinking. Dual aspect monism, which I believe is implicit in the mainstream Copenhagen tradition of quantum theory, is as equally counterintuitive as materialism, and tends to provoke just as much psychological resistance, as we shall see in the next unit.